So in the last lecture, we mentioned that we want to do multi-threading, and we're going to talk about that very briefly. Okay, we're not going to go so much into detail, but if you really want to understand it to a more clearer level, then I advise you to probably go with this video. I think this video is fantastic. It teaches you about this threading module in Python. I also have another post that talks about examples of threading using the Essential library and how to manage threads inside Essential. So this is available for everyone to read. So you can check out this post on my website, and just download the PDF, and you get a good idea of how threading and Essential works. I'm going to talk very briefly about what we want to do. So we take a look at the previous function. We did something like for ticker and ticker. Then we did something like get history, right? Now let's say this is time. Then we're going to say make the function call to get history, and this is going to last, say, X amount of time. And then we're going to make another request, and then we're going to make another request, so on and so on, and so on and so forth for 500 times. So this is going to last for 503 times for the entire SMP dataset. But the problem is, when you make this sequentially, then this becomes very slow. But if you look at the implementation of get history, what you will see is we make an API request. So when you do get history, right, inside this function, we have a request to an API, right, to Yahoo Finance. So what happens is there's some code here, and we make the request. And when we make the request, this request data packet will go to the Yahoo Finance server, right, and then this is the server. And then it will send back the data packet. Roughly speaking, okay, this is not that accurate, but roughly speaking, this is what will happen. So this is actually very time-consuming, right? So this is time-consuming, and while you're waiting for this to happen, no other activities are going on for our application. So what we want to do is we want to send a request, and while we send a request, so for example, we want to send a request, and then before it returns, we want to keep sending other requests. Okay, so let's say this is time, we want to send multiple requests, and then we can get back the request faster also. So I'm not very good at drawing, as you can see, but what's going to happen is if we create multiple threads, we can call get history, and then in another thread we call get history again, and so on and so forth until we overlap these requests. At some point of time, we're going to make the requests to the server, and then we're going to get back the results. But what is happening is we're not asking for data and then blocking. So we are simultaneously waiting for multiple requests at a time, and that is what the essence of multi-threading is about. There are actually a lot more nuances to this, and hopefully I will go into the details in maybe higher level classes. But for now, we're just going to treat this as a way to do multiple tasks at one go. And this concept is called concurrency. Okay, doing multiple things at a time is said to be a concurrency model. And you're going to see exactly how to do this inside Python. Now that we've talked about the Python concurrency model, what can we do? So this is what we want to make parallel, right? So in order to do this inside of a thread, we will need to, again, I really advise you to watch the video that I just recommended. That would really help to make things very clear. We're going to import this threading model, right? So this is the threading library, and inside the threading library, we're going to generate threads and send the requests in separate threads altogether. So in order to use the threading library, okay, let's put this inside a function, right? So def get histories and tokers, period starts, period ends, and granularity. So this takes in the same thing as get history, except these three parameters are lists. Okay, so and we want to get the results inside a list. So we want to populate this list. So right now we set it to none first, but we want to populate with a list. So in order to do that, we're going to say code a helper function that takes in the index and say get the history for the ith ticker. So this is the function call that we want to make. And once we get the results, we're going to set dxi into to the data frame that we get back from the get history function. Okay. So again, let's try to make this a little bit prettier. Now, so what we can actually do here is we can say, if we do this, right? So if we say for I in the range of length of tickers, we do helper I. What's going to happen is we're going to populate this. Let me just show you. Okay. Right now we're not using any threading just yet. So let's say we do. Okay. Let's get it here, and let's put this over here. So let's say we want to get the open, highlight, close, and volume data for just say the first 5 tickers. So okay, we're going to just limit that to the first 5 tickers. Here starts is equals to here start times 5. Here ends equals to that. We're going to let the default granularity activate. So ds. Okay, then we return ds. So let's see what happens here. Okay, let's make the function call. Oh, okay. We want to set 1 day, not day. So let's try it again. So we've made the function call, right? And it gave us a list of data frames for the first 5 tickers. Again, this is pretty fast, but if you're doing for 500, then it's not going to be very pleasant. So we can try this, and you can imagine that it's going to take quite long for us to do. So, we're not going to wait for it, but basically it's going to take a really long time. Right? So let's not try that. So, yeah. If I print this, then this will be easier to see that we are going to go one by one, and this is not going to be very efficient for us. And also, the library will be quite slow in order to prevent us from exceeding the rate limits. Now, we can improve this by using a threading model. So how do we use threading? We can collect the threads inside of threading.thread inside a list, and we create a target function, which is the helper function, and we want to pass in a argument. The argument is a tuple, so we pass in the argument, which is the index of the ticker. And we do this for all of the ticker inside the list. So this is going to be all the threads that we have. And now we want to start each of this individual process. So thread.start for thread in threads. So what we're going to do is we're going to create all the threads that we want to have, and we're going to start all of them simultaneously. So interestingly, what this does is we're creating 500 different threads, and each thread is tasked with making a request for a single ticker. And we're going to start all of them at the same time. We also need to, if we don't write this line, so we also need to ensure that we wait for all of the threads to finish, because if we don't do this, the program will terminate immediately. So we'll wait for all the threads to complete, all right? And then we can see what these data frames are. So we're going to do this again, and this time you should see very fast that it's going to make all of the requests. So this is much quicker than the previous non-threaded function. Okay, so now you can see that we will retrieve all of the 500 open, high, low, close, and volume data, and this was fairly quick. And this is the power of threading. Also, there are some requests where it was not successful, as you saw just now, and we want to sort of filter those things out. So let's say tickers equals to tickers I, or ticker, and tickers if. Okay, for I in the range of length of tickers if not just I dot empty. So this basically says that if we were obtaining an empty data frame, then we want to just filter those things out. And then we will do the same for our data frames, so df for df and dfs, not df to empty. And this will basically just return us the non-empty data frames for which we managed to obtain data. So we will return tickers and dfs, and this is very nice. Let me just elaborate more about these two lines, because I think this is where it might get sort of confusing. So inside this particular, what we did was we created threading.thread, and when we call this method inside the operating system, we originally had a main Python process. This is main.py. Right? This is the main Python process, and inside the process there is a main thread. So this is the main thread. And when we create this, when we make this function call, we're basically generating a new thread to. So this is associated with the main thread. When we do this, we're going to create new threads, and then we do this for 500 times. So, okay, hold on. Let me do this 500 times basically. So we create what is known as these are known as worker threads. So think of this as time, right? So think of this as time, and inside, if you think of this as time, then the main thread will be alive, and we're sort of generating these threads to survive, to start one after the other, creating these threads to start one after the other. And this happens when we do dot start. So when we start each of the threads, so we're creating each of the thread using this method, and then when we do dot start, they sort of begin their life cycle. And what dot join does is wait for each of these to terminate. So for example, when these threads are completed their task, they don't really need to be alive anymore. So we can sort of clean these up. But if you don't call this method, the main thread would not wait for these functions to will not wait for the worker threads to finish. It will actually just complete and terminate, and it will exit the application, right? And these threads will be basically just left for dead. In order to get the result back, we need to wait until the longest living worker thread finishes, and we do that by calling the join method. So that is the essence of these two lines. Okay, so now we can say we want to obtain a good data set. So we can do get ticker dfs, say from start to n, and this is the function we want to call if we want to get our data set. So let's start from here. We're going to do tickers, and then we do get histories. So we get tickers and dfs and get histories. We'll do start, and we'll make this function call. Starts ends, and okay, so this will be start times length of tickers, and the ends will be this. Okay, then we will return tickers, and we want to return a dictionary of ticker as the key and the data frame as the value. So let's move this to the top. Let's move this to the top. So I have this. All right. And now this we can call get ticker dfs from a start to n. Here start, and it goes to ticker. Okay, so this is our code to get our data set, which is quite simple. I mean, there's a little trick here where we use multithreading. Other than that, it's fairly standard. So let's run this one time, and we should be able to get all of our SMP data sets. Now that we have obtained the data, we can really do interesting things with the data here. And from the next lecture, we will see how to program a quantitative backtesting module.